Hi everyone, welcome to your Play Posit for the week. Happy Monday. I hope that you had a great weekend and I can't wait to see you on Wednesday or Thursday to hear all about it. But for now, go ahead and grab your notes. We are going to get started on lesson 3.2, the first lesson in unit 3. So just a quick note, remember today on your plan is the unit 2, but you do not, or the review, I believe. Review and the test. I want you guys to make sure that you're ready for that test. So take some time. If you don't feel ready, then study some more, reach out for help, review, and then take it. Remember, you have until Friday to complete anything that was assigned this week. Our very first end date is approaching in about 3 weeks on October 14th. That's a Friday. So after the 14th, you will no longer have access to retake any graded assignments that were assigned from the beginning of the year through the 7th. So we talk about our weekly due dates, right? And then because of the flexibility of our program, let's say you were sick, you went out of town, you needed some more time on some certain lessons, you do have that built in there where as long as you have everything turned in by the 14th, it will count for full credit. But after the 14th, those graded assignments close and you no longer have access to them. So now is a really good time to make sure that you're keeping up with the work, you're looking back at previous assignments, make sure you don't have any zeros, make sure you're looking at anything with those low grades, not because I want you all to have perfect scores. That's not what that's about. But if you get a low grade on something, right, that's an indication you're like, wait, I should probably review that material. I should probably watch some videos. I should probably reach out for some help and practice. Because if you earned a low grade, well, maybe you rushed or maybe you just need some more help in that area. And so now is the time to look for those assignments and really tackle them. As always, don't forget, we have our Desmos graphing calculator. I'm sure everyone has this linked by now on your browser tab. You want to make sure it has the green bar. That's the Virginia version. And remember, you will only be allowed to use the online calculator for your SOL unless you have a calculator accommodation. So the purpose of me reminding you about this all the time is I want to make sure you're super comfortable using this calculator because this is the one you're going to have. And there are no restrictions on calculator use in this class. You can use it on anything, any test, any quiz. We do want to be mindful, right? We're not using it as a crutch. We're using it as a tool to help us check our work. So today we are going to work towards modeling some real-world linear equations to analyze and make predictions. We're not going to actually get to do this today, but that's kind of our end goal with what we're going over. Here's an example I like as we approach October. Think about the amount of candy left in your Halloween bucket over a period of time. So maybe you eat 1 piece per day, or 2 pieces per day, or 1 piece per hour. I don't know. We can model that using a linear equation. So in order to work towards this goal, first we're going to recall parts of a graph, find some intercepts and slopes, and just, we're always awesome. So, and this is my meme. I see you have some graph paper. You must be plotting something. All right, before that, we're going to do our flashback of the week. This takes us to previously learned content. This is solving an equation. You can see there are variables on both sides of the equation, and our goal is to get x by itself. But before we can get x by itself, we have to clean it up a little, right? We have to combine any like terms that we see. So we can go ahead and do that, right? 1x plus 3x is 4x. I'll just, 2 minus 3 is -1. And now we can remember PEMDAS, so we did parentheses. We were able to combine those. And now we'll do multiplication. 2 times 4 is 8x. Negative x times -1 is a positive x. And look, we can just continue combining. We have 1x plus 2x is 3x. So we're getting it cleaned up a little bit. It looks a lot easier to work with. Let's move 3x over by doing the opposite, right? It's a plus 3, so we will subtract 3. 8 minus 3 is 5x, and move the 4. Oh my, all of this to get 0. And then we'll divide both sides by 5. But we are going to check our work, so we end up with x equals 0. Let's plug 0 in. Let's see, 4 plus 2, we'll put 0 here, 0 here, everywhere you see an x. And we will see if it's true or false. So remembering PEMDAS, multiplication here, so that's 0 plus 0. Two minus 3 is still negative 1. 2 times 0 is 0. This is 0, right? And 2 times 0 is 0. So you're left with 4 on the left. Bring that 0 down right there. 0 times negative 1 is 0. That's 0. So you get 4 equals 4. Remember, you can also plug this into your calculator to double check. Nice work. All right, so let's recall. You all have done a lot of this already in whether you took Math 7, Math 7 Advanced, maybe you took Math 8 as a 7th grader. So you have touched on some of these topics already. So we're going to review which ordered pair is a solution to this equation. So remembering that an ordered pair starts with the x and then the y, right? We go alphabetically. X comes before y. And so each of these has an x and a y value. There's kind of two ways to do this. I'll show you both. So we can plug these in and see which one is true, which one is false. You could like plug in x and solve for y and see if you get 1. Remember, a function has an input, that's our x value, and it has an output, that's our y value. So if we put in 11, let's try putting in 11 for x, we should get out 1 for y. Let's try it. Plus 3y equals 16. And then we'll subtract 22 from both sides. And you get negative 6. Divide by 3. You get y equals negative 2. So that is not an output of 1. Nope. So that's one method. Another method is to plug in the x and the y and see if you get 16. Let's try that. So this is A. Here's B. So we'll plug in 3 for x, 2 for y. 2 times 3 is 6. 3 times 2 is 6. Oh, 12 does not equal 16, so it is not B. That seems like a shorter method. Let's try it for C. 2 times 5 plus 3 times 2, is that 16? 2 times 5 is 10. 3 times 2 is 6. Oh, it's looking promising. Yep, that does work. Let's try D just to be safe. 2 times 7 plus 3 times 2, does that equal 16? This is 14 plus 6. No, that equals 20. So it is, in fact, C. So I'm going to show you also how to look at this on the Desmos graphing calculator. All right, so here's our Virginia green bar graphing calculator. We're going to type in the equation as we had it, 2x plus 3y equals 10. Oops, I put minus. Equals 10. There's the line. And let's look at where do we think are some important parts of this line. I mean, they have dots on them, so that looks promising. These are intercepts. So this is crossing the y-axis at 0, 3.3, and this is crossing the x-axis at 5, 0. Look what happens if we put x equals, oh, of course, I already forget the number. What was it? 5. one quick thing. This should be, I wrote it down wrong. That should be 16. There we go. Okay, so when x equals 5, what is y? And look, here's the line x equals 5. There's our coordinate point. So when that line crosses at 5, we get the value y of 2. So that is another way you can do these problems. If we tried 3 for B3, let's see what happens. You can see that it is not 2. It is 3.333. So you can put in the equation just as it is. It will graph it for you. And you can put the x value and see what is the y over here. So really cool way that you can confirm your work and use that Desmos calculator. All right, back to our graphs. So we were talking a little bit about this when we were looking at the Desmos graph here. But looking at these, some important points here. This is our y-intercept. Remember, the vertical line is the y-axis and the horizontal line is the x-axis. So this is our y-intercept. It's where it crosses the y-axis, that word intercept. And what is the coordinate point here? What is the x and what is the y? Remember, you start at 0 and you don't go anywhere in the x direction, so that means x is 0, and you go up 4 units. Let's look at the x-intercept. The coordinate point here, we went over -5, and then we did not move in the y direction at all, so it's 0. Just to review quickly the quadrants, remember this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. It goes in the counterclockwise direction. And remember, this center point here is called the origin. It's where we start all of our coordinate points. So let's look at this one. We only have an intercept here of 0, 0. Same quadrant 1, 2, 3, and 4. Remembering slope, this line has a positive slope, because as you work or walk from left to right, the line is going up. So from left to right, from left to right, the line goes up. That's sort of the definition of a positive slope. This one has a negative slope. From left to right, the line goes down. And I always pretend like I'm taking a walk along the line. And if you were to walk down this line, you would go down the hill. So let's try finding some more intercepts graphically. So intercepts, remember that's where it intersects or crosses the line. So the y-intercept is right here. And what is this coordinate point? Always start at the origin. To get to this point, remember, you always go in the x direction first because that's x comes first in the coordinate point and x comes first in the alphabet. So we don't move anywhere in the x direction, and then we move up 2. Our x-intercept, we move 3 in the x direction, and then we stop. We don't go up or down, so we move 0 units in the y direction. Over here, our y-intercept, let's say it's going through right here. It does look a little off. That is also 0, 2. And then our x-intercept, we go over -3, and then we do not move in the y direction. What are you all noticing about the intercepts and the coordinate points? Anything? Any common themes? Let's look back here. The y-intercept, x is 0. The x-intercept, y is 0. Same here. Y-intercept, x is 0. X-intercept, y is 0. So it's like the opposite is happening for 0. Look at these lines. This is a vertical line. The slope of a vertical line, pretend you were standing and you were going to take a walk on the, oh, you can't. You fall right off. The slope of a vertical line is undefined. Slope of a vertical line is undefined because you fall. Woo. The slope of a horizontal line, let's say you were standing on this line. Look, you don't have to walk up or you don't have to walk down. You're just standing. So the slope of a horizontal line, whoop, where'd my flag go? There it is. The slope of a horizontal line is 0. There's no change. Remember the definition of slope from previous math courses? It's the change in y, you can write this here, over the change in x. There is no change. None. Because it's just there. It's horizontal. So a horizontal line, the slope is always 0. A vertical line, the slope is always undefined. Always. So let's write some common themes for our intercepts. X-intercepts occur when y equals 0. They cross the x-axis, and we can write it in the form x, 0. Y-intercepts occur when x equals 0. They cross the y-axis, and we can write it like this. Okay. So let's find our intercepts algebraically. So like the big deal here is they x-intercepts happen when y is 0. Y-intercepts happen when x is 0. We saw that. So to find it algebraically, all you do is plug in 0. So first, to find the x-intercept, we set y equal to 0. So let's do that. We're going to plug in 0 for y and see what x is. Because remember, we said the x-intercept was x, 0, right? So all we're missing is the x. So let's find the x. I don't know why I put a parenthesis there. That's okay. There we go. All right, we're going to solve for x. So this is 0. We'll add 2 to both sides to get x by itself. And divide by 3. So x equals 2/3. So our x-intercept is 2/3, 0. Now let's find our y-intercept. I'm going to run out of space. Always. To find the y-intercept, you set x equal to 0. Because it's of the form 0, y. So we're just missing the y. So let's solve for y. Plug in 0 for x. This is 0, right? And we'll divide by 4. Y equals -2/4 or -1/2, right? It reduces. So our y-intercept is 0, -1/2. Now, something really cool we can do, which you could probably guess I was going to say, is let's go look at Desmos. So we're going to type in the equation exactly as it was given to us, 4y plus 3x equals 2. 4y plus 3x equals, oh, -2. Did you see that? Every time. 4y equals 3x minus 2. You got to make sure you type it right. That's the big deal here. 4y equals 3x minus 2. There. Okay. So here is our y-intercept. 0, -1/2. That's what we got. And here's our x-intercept. 0.667, 0. Well, let's see. Is 2/3 0.667, 0? Look, we can also do this. 2 divided by 3, 0. And plot the point. Oh, did you see that? It plotted it right over our intercept. You turn it on and off like this, and you can see that's the intercept. Isn't that cool? So this is another way you can confirm your work. 0, comma, negative 1/2 we had. There it is. Now, I know this seems kind of magical and mystical. I don't want you to just use the calculator because you're going to see problems where you're going to need to know the method. So you need to know the method, but the calculator is a great place to start if you've forgotten the method, or it's a great place to check your work. So let's do this one. I'm going to need a new slide. I think you all have more space than me. Hope you do. Yeah, I made those notes bigger for you. Okay, so we have 8y equals 2x plus 10. Let's make sure I copied it right. Okay, now we're going to find the x-intercept. We find the x-intercept by setting y equal to 0. Remember the opposite number. So 8 times 0 equals 2x plus 10. And we're going to solve for x. This is 0. Subtract 10 from both sides. And divide by 2. X equals negative 5. So our x-intercept is that coordinate point, negative 5, 0. So sometimes the question will ask you for the coordinate point. Sometimes it will ask you for the x value. It just kind of depends. So make sure you're paying attention to what they're actually asking for. The x-intercept we're going to find by setting, the y-intercept we're going to find by setting x equal to 0 and solve for y. Just like these tiny little solving problems. So this is 10, right? That's 0. And we'll divide by 8. And this reduces, you can divide both of these by 2. So you get 5 over 4. So our y-intercept is 0, comma 5 over 4. This is the y-intercept because we have a y value. This is the x-intercept because we have a x value. Okay, so let's plug this into Desmos to confirm. Come up here. Remember, you can type it exactly how it was written. That's new for our TI-83 users or others. You used to have to solve for y. Desmos, you can plug it right in. There's our negative 5, 0, and then let's make sure 5/4. Oop, there it is. Whoa, whoa, whoa. There's our y-intercept. So it's just a nice way to confirm your work. All right, we had one more. Y equals 2x plus 6. So to find our x-intercept, we're going to set y equal to 0 and solve for x. So instead of y, I put 0. We'll subtract 6 from both sides, and you get 2x equals negative 6. Then divide by 2, and x equals negative 3. So our intercept is negative 3, comma 0. Our y-intercept, we are going to set x equal to 0. All right, and you get 0 plus 6. Oh, that was easy. Y is 6. So we'll have 0, comma 6. Those are two intercepts. Y int and the x int. You can always confirm with your calculator. So talking more about slope, what do you notice about these pictures? I have some real world examples of slope. Here, the horizon, this is the most horizontal slope I could find. Of course, we know that nothing in nature is ever perfectly anything, right? So that's probably not perfectly horizontal, but close enough for imagery purposes. Look at this. These are some like real life mountain climbers up Mount Everest. This is a positive slope. Here we have a negative slope down a hill. I guess it depends. Yeah, from left to right, we have our negative slope. Look at this roller coaster. Slope is very important when you're talking about roller coasters. If you have too steep of a slope, your roller coaster cart, the gravity will not work in its favor. Okay, so they have to make sure they have the right slope. Same with these kind of signs. If you've seen these on the highways, we want to make sure that the slope of the road is safe enough for vehicles to travel upon. So finding slopes graphically. Again, this is review. You have done this before, but remember, slope is rise over run or change in y. That's why it's rise. Remember, the y-axis is up and down, and that's why it's rise, because you rise up over the change in x, and the x is on the bottom because you run horizontally. Some people also wrote it like this, delta y over delta x. Delta means change, so you'll see that a lot as you get into higher mathematics, delta y over delta x. This is a triangle, but it's also the Greek letter delta. All right, so to find the slope, you start at one coordinate value and you try to get to another. I just picked the intercepts because they're nice. They're like right on the coordinate grid. So we're gonna rise first. We're gonna rise 1, 2, 3, 4. So we rose 4 units. That's gonna go on top. And we're gonna run horizontally. 1, 2, 3, 4, 5. 4/5. The slope, remember which letter we use to represent slope? Lowercase m. So the slope equals 4 over 5. Let's try this one. We're going to pick a coordinate point that's on a grid mark. Like, see, we wouldn't want to pick this one because that's like halfway between. So let's pick this one and this one. That looks good. Now we're going to rise first. You're like, okay, let me rise. Let me go up. Well, our goal is to get from one coordinate point to the other. So you could start here and rise and run, or you could start here and go down and over. So rise is representing the change in y, and y we know goes up and down. Sometimes that word rise is a little confusing. So you can start here and go down and over, or you can start here and go up and over. It's up to you. Well, you get the same answer, right? If we start here and rise 1, 2, 3, 4, 5, rise 5, we went 5 up, so that's a positive 5. And we would run 1, 2, 3, 4. We ran to the left, so we went negative 4 units. When you go to the left, you're going in the negative direction. And this is perfect because if you look at the line is going down. Lines that go down are negative. Okay, big deal. Lines that go up are positive. So if you have a line in your picture that's going down, you want to make sure there's a negative. Did you know that this is the same as this is the same as this? These are all the same. The negative in the bottom, right out front, or on top. They all mean the same thing. The fraction is negative. So if we started here and went down 1, 2, 3, 4, 5, down 5, so that's negative because we went down. When you go down, you go in the negative direction, and over 1, 2, 3, 4. So see, you get the same answer. Totally up to you. Ooh, let's find these slopes. Do you remember? Remember the slope of a horizontal line is always what? 0. There's no change in y over change in x because it's 0. How about the slope of an undefined? Oh, I just said it. The slope of a vertical line is always undefined. Always. One way I remember this is like I could draw a big old U. Look, vertical line, undefined. All right, so the slope review. We know all these, right? We know that slope is rise over run. We know it's change in y over change in x, which also means change in y over change in x. So a formula comes from all of this, which I know you've learned as well. Change. To find the change in something, we are going to subtract. So we're going to subtract some coordinate points. So when you have two coordinate points, x1, comma y1, and x2, comma y2, these are little subscripts. They don't really mean anything. They're just like labels. I mean, they mean something, but it's a label. It's saying, okay, this is your first coordinate point, and this is your second coordinate point. And it's an easy way for us to keep everything straight and tidy. So to find the slope, we're going to subtract the y values and divide by subtracting the x values. See, change in y over the change in x. So let's try a quick example. Let's say we have, ooh, I know. Let's go back to this one, and we'll take these coordinate points, 0, comma 4, and negative 5, comma 0. And let's see if it's 4/5. 0, comma 4, negative 5, comma 0. Okay, so we're going to label this. I like to label x1, y1, x2, y2. This is my first point. This is my second point. Once you have it labeled, you really just plug it in. Look, y2, okay, that's 0, minus y1, okay, that's 4, over x2, that's negative 5, minus x1, that's 0. 0 minus 4 is negative 4. Negative 5 minus 0 is negative 5. And then negative 4 divided by negative 5, it gives you a positive 4 over 5. Let's go back. It matches. Remember, negative divided by negative is a positive. So let's try some. Let's find the slope algebraically now. This first equation should look super familiar. Do you all remember this equation? Y equals mx plus b. Write that on your paper. There's our familiar m. M is the slope. M is the number that's in front of the x when it's in this form, and m is the slope. B is the y-intercept. So guess what this is called? This is called slope-intercept form. Isn't it so nice when the names make sense? Slope-intercept form. Oops. Form of a line. And we're going to learn about all kinds of forms of a line in class this week, in live class. So you look at this, look, it's already in slope-intercept form. That's m and that's b. So we can pull the slope right off. It's negative 5/2. That's it, right here. That form of line is super handy because you can just get things right off of it. And look, the y-intercept is negative 5. How would we write that as a coordinate point? If the y-intercept is negative 5, what is x? X is 0. Remember, the y-intercept, x is always 0. The x-intercept, y is always 0. Okay, now let's try these. This is where we're going to label and use our formula. x1, y1, x2, y2. And I'll write that formula here. Change in y over change in x. This is slope. So once you have it, you just plug it in. That's why I like to label negative 4 minus 7 over negative 6 minus a negative 4. Be careful. So negative 4 minus 7. I remember keep, change, flip. Keep, change, flip. You can also plug that in your calculator. What is negative 4 plus negative 7? That's negative 11. Keep, change, flip. And on the bottom, you get negative 2. So I'm just going to double check my work. Y2 is negative 4. Y1 is 7. X2 is negative 6. and x1 is -4. Yep, that looks good. Let's do this one. Oops. x2, y2. All right, so we'll have 15 minus -10 over -15 minus 6. Keep, change, flip. 25 over, keep, change, flip. 21. That's not a very pretty number, but that's okay. Slope's usually fraction, but not always. It's always a good idea to double check. Let's see, 15 minus -10. Yep, and -15 minus 6. That's it. All right, everyone. Thank you so much for sticking with me, for working along, writing in your notes. It's really important that you're doing these play posits because, as you can see, it's basically like another class together. Please reach out if you need anything, and I'll see you this week.